Hello students, I am Dr. Rajaram Dhok from Savitribai Phule Pune University affiliated Agricultural Development Trust Shardabai Pawar Mahila College Sharda Nagar Baramati. Let's start. Ionic Solids Lecture 4, Structure of Ionic Compounds. So in this lecture we studied about the structure of ionic compounds. So these ionic compounds, when we consider, then these ionic compounds are made up of positive and negative ions. And these positive and negative ions held together by a bond, and that is ionic bond. These ionic compounds contains aggregates of cations and anions in the crystals, and that is called as ionic crystals. So in this ionic crystal, they do not contain discrete molecules, but the structure extends throughout the crystal. In the ionic solid, positive ions are surrounded by negative ions. Again, negative ion is surrounded positive ions, and this is continued up to a long distance or infinite distance in all the three dimensions. So normally each in this structure that is surrounded by greatest possible number of oppositely charged ions, and that oppositely charged ions when surrounded with central ion, then this number is called as coordination number. So when one cation is surrounded by 6 anions, then coordination number of that ionic solid is 6. Again, anions is surrounded by 6 cation. So same is observed that cation and anion both have same coordination number. So the ions in the ionic solids, they are arranged in a regular and definite pattern. So we take example of sodium chloride. So such crystals of sodium chloride that consist of symmetrical arrangement of sodium and chloride ion. So in this sodium chloride structure, each sodium ion is surrounded by 6 chlorine ion and vice versa. The structure of ionic compound that is governed by the most stable arrangement. In that arrangement, cation-cation, anion-anion repulsion is minimized and the cation-anion attraction is maximized. Means in the ionic compounds, the same type of ions, they have maximum repulsion, and opposite side of ions, they should be maximum attraction. Then in that case, stability of that ionic compound is more. You see some structures. Here some ionic solid structures are shown. So in this first structure, shape of this structure or shape of this ionic solid is tetrahedral, because here one ion is surrounded by other 4 ions and they are in the tetrahedral direction. Then this second structure. In this second structure, here one ion is at the center and other ions are surrounded with this. In the other ions, 4 are in the plane in square and 2 are in the pyramidal positions. So this shape is octahedral. So such type of ionic solid has octahedral shape. Then third structure. In third structure, one ion is at the center and oppositely charged ions are at every corner of cube. So at every corner of cube there are 8 ions. So this type of ionic solid have shape cubic arrangement or cubic shape. So such type of tetrahedral, octahedral or cubic shapes are observed in the ionic solids. Now we see this table. In this table, lattice of different ionic compounds are shown. And in this lattice, their coordination number and radius ratio of that ions are also shown. So we see this different lattice. First lattice is rock salt, that NaCl. NaCl is called as rock salt. So in that, coordination number of Na and Cl both is 6. So we have written here 6 as 6, means one Na is surrounded by 6 Cl and one Cl is surrounded by 6 Na. And in this case, the radius ratio is in the range of 0.42 to 0.73. Second lattice is calcium chloride, CaCl. Its coordination number is 8 as 8. Means one CS is surrounded by 8 Cl and every Cl is surrounded by again 8 CS. In this case, radius ratio is greater than 0.73. Third crystal, zinc blend, that is the ZnS crystal. Its coordination number is 4s4, means one Zn is surrounded by 4s and every s is surrounded by 4 Zn. Here radius ratio is 0.21 to 0.42. Then Urdhite structure, that is also zinc sulfide structure. Here coordination number is 44 and radius ratio is also 0.21 to 0.42. Then fifth structure, fluoride structure, that is calcium fluoride type structure. Here coordination number is 8s4. In this case, here ratio of cation and anion is 1s2. Means there is one cation that is surrounded by two anions. And in this, radius ratio is greater than 0.73. The last type of ionic compound or lattice type is rutile structure, that is TiO2 type. Here coordination number is 6s3. Means one titanium is surrounded by two ions, oxygen ions. And so such type of 6 to 3 ratio is formed and radius ratio in this case is 0.42 to 0.73. Now we see the types of ionic crystal structures. So depending upon the shape, different ionic crystals are classified into different types. So in that, first type is sodium chloride structure. And this sodium chloride structure is FCC structure. Second type is calcium chloride structure and this is BCC type structure. Third, zinc sulfide, that is ZnS structure, and that zinc blend structure is observed, and in that zinc blend structure, this is Ccp structure. Then fourth type, zinc sulfide structure, and this zinc sulfide structure is of different type than the zinc blend, that is called as Urdhite structure, and this Urdhite structure is HCP structure. Fifth type is calcium fluoride, CaF2. This is fluoride structure, that is called as fluoride structure. Sixth type is titanium dioxide, TiO2, and this titanium dioxide is rutile type of structure. So these are the 6 types. So mainly we see about the first two structures in details. So we see the sodium chloride structure or FCC structure. In this FCC structures, the zinc blend structure is observed, and in that zinc blend structure, this is CCP structure. Then fourth type, zinc sulfide structure, The radius of sodium ion is 0.96 degree Angstrom and radius of chloride ion is 1.81 degree Angstrom. When we calculate the radius ratio of this sodium and chlorine ions, then we get the radius ratio Rna plus divided by RCl minus, that is equal to 0.96 divided by 1.81. So we get the value 0.525. So this 0.525, this value lies between 0.42 to 0.73. And so the sodium chloride crystal has octahedral structure because here coordination number is 6s6 and radius ratio is in the range of 0.42 to 0.73. Then second, here we see the actual structure of sodium chloride. We see here this black colored ion is sodium and this hollow light colored ion is chlorine. Now, if we see the arrangement, then here smaller size of Na and Cl is shown. Actually, its structures are, or its size is larger, and Na is touch with Cl, Cl is touch with Na, and this three-dimensional structure is formed. So one Na is surrounded by 6 Cl. Again, every Cl is surrounded by 6 Na, and such type of cubical structure or face-centered cubic structure is formed. Now, second type of structure, that is Caesium chloride structure, and this Caesium chloride structure is Bcc structure. So, how this is Bcc structure? For that purpose, we see the radius ratio of this Caesium and chlorine. So, radius of Caesium ion is 1.69 degree Angstrom. Radius of chlorine ion is 1.81 degree Angstrom. So, we calculate the radius of cation to anion ratio. So radius of RCS plus divided by RCl minus, that is equal to 1.69 divided by 1.81, and by calculation we get this 0.93. So this 0.93 value is close with 1. This suggests that coordination number of this compound or of this ionic solid should be 8. So Caesium chloride crystal has cubic structure, and here each Caesium ion is surrounded by 8 Cl minus ion, and every Cl minus ion is again surrounded by 8 Cs plus ions, and this is continued in all the three directions, and there is formation of this Bcc structure. You see this structure, shape of CSCl or BCC. Here at the center, here dark colored Cs plus is shown, and at every corner of the cube, here light colored or hollow chlorine ions are shown. Now you see here one Cs is surrounded by this 8 Cl ion. Now you see this second structure, this is also same but shown in some different ways. Here this hollow ion is chlorine ion and this black color dark is the Cs ion. Now you see this one Cl ion is surrounded by 8 dark colored Cs ions. Again, when we consider this one Cs ion, then this one Cs ion is surrounded by here 8 Cl minus ion. Means in this BCC structure, every ion, one Cs is surrounded by 8 Cl ion, and again every Cl ion is surrounded by 8 Cs plus ions, and vice versa. This is continued in all the three directions, and there is formation of crystal lattice of CsCl, and This shows Bcc type of structure. Now, third example, zinc blende structure, that is Ccp structure. So this is the shape of this. So smaller size ion is zinc and larger size ion is S. Now see, this smaller size ions, when attached with larger size ions, then one smaller size ion is surrounded by four other ions or sulfur ions, and this is continued, or this is vice versa. The arrangement of this CCP structure is observed, and that all the ions finally it forms cubical structure. Then titanium dioxide or TiO2 rutile structure. In this dark colored, black colored titanium ions are shown and larger size oxide ions are shown. Now we see here one titanium ion is surrounded by how many oxide ions, and this is shown in this diagram, and in that ratio of titanium and oxide ion, one titanium ion and oxide ion is ratio is 1:2, means one titanium ion is equivalent to 2 oxide ion, that is 1:2 ratio is formed, and accordingly the titanium and oxide ions are surrounded with each other, and this rutile structure is formed.